Hey everyone, this is Nanda Arpita. Today we'll be talking about stack. So now what is a stack? Before going into stack directly, let us relate how it works in our daily life. So let us take some files like this. So how did I place all these files? First I placed the blue file, the orange file, later I went on to the top. So this is how it went. So what I actually mean to say is, when I want to remove some file, I don't start removing the file from the bottom. Rather, I remove the file at the top, then the bottom one, then finally I come to the bottommost file and remove it. That is what is happening in the stack. There is a block which is empty initially, and after that I'll have to enter some of my elements. So what is the relation between this and that? The mechanism is that the element which has been last sent into the stack is to be first taken out of the stack. Yeah, here consider this to be your stack, the bottom one, and all these things are to be filled with your elements. Once you're sending something inside your stack, that means you're pushing something inside that. So the term is push. And when you're taking something out of the stack, then the term is pop. So every time you put something, that is called as push, and every time you take something out, it is called as pop. So this is the concept or the terms used in the stack. Now here in this program, I want to put some elements into the stack which is already being created, and I need to pop the same elements, and I need to display on the screen for the user to read what kind of elements or what elements I've entered into the stack. So before just blindly going through the program, let's first look at the output. Whenever you design a program, just see that your output is known to you beforehand. So once you know the output, looking at the output, just construct your input, but never ever go to the input construction directly, because that will lead to confusion. When you need the output, think about your output, then you need to imagine what you need to give, what kind of logic you have to use. That is what you have to do. So here when I go for my output, I have something like this. It says that this is the menu, and 1 push, 2 pop, 3 display, 4 exit, and it is waiting for my choice. That means I've added a switch statement so that it can switch between any choice I've entered. So for that, what have I done is, here I have ch, and that is the variable which I'm using in the switch. So I have 3 cases wherein I can push the element, I can pop the element, or I can display the element. Okay. If I have not chosen any one of them, I say it is default. I store it under default, which is the syntax of switch statement, and I say that it is an invalid choice. And here, coming to the start of the program, what I've done is I said include IOStream, which is our common header file including in every program, and after that using namespace std where all these files are included, and I defined that size of is to be 5. Now my size of stack is 5, so I've told this beforehand. So now I say void push, void pop, and void display. I have given int item for all of them and int stack to be 5, which has already been declared. Now coming to the program, I've already declared top to be -1, and in the program, as I've said, I've used the switch statement, and item will be the input taken by given by the user, like what all elements you have to store in the stack, and I've already told that stack is 5. Now I run a loop to store the variables. After that, I repeat. This is a label which I am using for it to run again and again once you enter the elements. So this is the menu which has been displayed at the starting. Here it is. So to display this menu, this bar, I've used this line, and I'm taking the value ch, and whenever I take 1, 2 or 3, these functions are called. So let us go to the functions. Now when I say 1, it is asking me to push an element, and I'm pushing an element 3. Now I display what is happening. So when I push this element 3, look at this, I have the 3 on my display, and others are 0. Like I've initialized it to be 0. Now Let us go to the functions that are being called over here. When I say in case 1, I go to push, and for case 2, I go to the pop function. For case 3, I go to the display function. So first, let me go to the push function. Yeah, here I have the void push. What actually happens here is, here I have said that item is int and stack of 5 is int. I say when top equal to size of -1, then stack is overflow. Let me explain. Now what is the value of size of? The value of size of, which I have already declared at the start, the value of size of is 5. And I say -1. And 5 minus 1 becomes 4. If my top is 4, then I have to say that stack is overflow. That is like, so let us assume that this is my stack and I have 5 places to fill the items. Now when I push some item, it comes over. If I assume that I push 0, it comes over here. The next element comes over here. The next element comes over here. The same thing happens, and when you come over here and you take one more input, that means there is no other space for, okay, this is filled, and there is no other space for other element to enter. So beforehand, we say before pushing something, we display a result telling that it is overflow. Stack is overflow. That is what it is saying. If not, so if I say, if this condition is true, say stack is overflow. If that is not happening, and if you have space inside the stack, then allow me to take the items. So we are entering one output, like enter elements to push. So the user will be ready to enter the output, input, and the input will get stored in this item. And every time he enters, this item will get stored on stack of top. Look, the item, if it is 3, he is entering. It gets stored on the stack of top value. If this is my top value where the element is there, okay, to be more clear, let me say that these two things are filled. I need to fill something over here. So now what is my stack value? This is my stack value, stack of top value. So when I enter the next element, the item will be stored in the stack of top value. That is what I actually meant. So now in here, for the second, now we know how we do push. Now we are going for the pop function for the case 2. Now in case 2, we say that if top equal to -1, we are saying that stack is underflow. That means to pop out something, you need something inside the stack, isn't it? So if you don't have anything inside the stack, then what are you going to take out of the stack? So if the top is -1, then you're going to say there is nothing inside the stack, and you're going to display that to the user. And if not, the item will be stored in the stack of top, and the user will be asked to give the input. So once it is done, we are asking the user to, if he wants, he can take the output of what all he pushed inside or popped out. Once he pushed inside, he can pop them out, and once he can display what are remaining in the stack. So for this, we are telling the stack is, we are initializing it to 0, and for every I less than 5, we are incrementing it by 1. And for this loop, each time it runs until it is false, we are printing the stack value I. So here, let us go for the output and see how this works actually. So in my stack, I am going to enter my elements. So what it means, I am going to push my element. So first, I am entering the choice 1, and I am pushing it. So enter any element to push. So what am I pushing into my stack? So let me push the element 9. Okay. The second, I am again going to push something into my stack. So enter any element to push, and I am going to enter 1. So again I need to enter something into my stack. So I choose 1, and I say 7. Again I need to enter. Again I enter 7. Again I need to push something into my stack, and I say 2. This is how I push the elements. See, if I want to enter something, look at here. If once I've entered 5 elements, and I entered another 1 so that I can push. When I said that over here, I'm sorry. Over here, when I said I wanted to push something, it said stack is overflow. So you cannot push any more item into it. So when I need to pop something, I say 2. Okay. So once you pop something out, that means you are deleting the same thing from the queue. All the elements you've entered into the queue, you are removing it from from the stack. This is how it goes. I am removing each element. That means first 2 came out, next 7 came out. That is the way I am going to move. Now if I need to display the remaining elements in the stack, I say 3. So the elements in the stack will get displayed, and the free spaces in the stack that which are not being filled or which has been popped out will be displayed to be 0. And once I need to exit this loop or exit the switch, I say 4. So here you have the statement, end of program. This is how it goes. Thanks for watching. Bye.